Hi everyone, in this video we are going to know about Ohm's law. It is a topic from chapter Electricity of class 10th Science of NCERT textbook. After this video you will be able to explain Ohm's law. You will be able to plot Ohm's law variation between voltage and current. You will be able to define resistance and resistivity, and also you will be able to distinguish between them, and you can also predict the factor on which resistance and resistivity depends. Ohm's law. In 1828, a German physicist named George Simon Ohm introduced the concept of Ohm's law when he was trying to find an analogy between the thermal and the electrical conduction. The thermal conduction stands for the conduction of heat, whereas the electrical conduction stands for the conduction of electrical energy. So, Ohm's law is a relation between potential difference and current, and it is named after him. So, let's talk about potential difference and current before going to this analogy. Potential difference. The potential difference between 2 points in an electric field is defined as the amount of work done in moving a unit positive charge from one point to other against the electric force. It is measured in volt and measured by an electric device called voltmeter. Let's understand this definition. You can see a picture over here. Consider a positive charge plus Q placed at a point O. Since we know this charge is a source of electric field and the direction of the given electric field will be radially outward from the point O. Consider another test charge placed at point A, where the directions of electric field is outward in the direction OA. If you are willing to move that charge from point A to B against this electrostatic repulsion, we have to supply some additional amount of energy, or a work is needed to be done in moving a charge from point A to B. So the work done in moving the charge from A to B through a distance dx is equals to the potential difference. Okay, so the potential difference is moving that charge from A to B through a small distance dx against the repulsion of electric field E. Now, what is electric current? The current is defined as the rate of flow of charge. So, how many charge is flowing in 1 second through a cross section of a wire is the measure of current. So, I is the ratio of charge to the time, where charge is measured in coulomb and time in second. The SI unit of current is ampere, and it is measured by electric device called ammeter. The statement of Ohm's law. It states that at a constant temperature, the current I flowing through a conductor is directly proportional to potential difference V between the two ends of the conductor. Let's understand this statement. Here we have highlighted the four words: constant temperature, current, directly proportional, and potential difference. We have discussed the current and potential difference. Let's talk about why constant temperature and how directly proportional. So constant temperature is needed in order to maintain the physical parameters constant. What does it mean? It means a change in temperature affects the physical condition of the conductor. Increasing temperature stretch the wire length, and decrease the temperature contract its length. So the change in temperature affect the length and the area of cross section of the wire. So in order to maintain the validation of Ohm's law, the constant temperature should be there. Now, what is meant by directly proportional. Actually, it is a relation between the current and the potential. Directly proportions means if we increase the potential difference, the current will increase automatically, and if we decrease the potential difference, the current will decrease automatically. So if one goes up, other will also go up. If one goes down, so the other will go down. So the potential difference is directly proportional to current. And if we remove the proportionality, we get another physical quantity called electrical resistance. So V equals to IR is the mathematical form of Ohm's law, where V stands for potential difference, I is current, and R is the resistance of wire. Now if we plot the graph between voltage and the potential difference, we will get the graph shown in the screen. You can see here the relation between potential difference and current is linear in nature. The red line shows the linearity of potential difference and current, which will gives you the value of resistance at any point. So if you are willing to find the resistance at any point, all you have to do is you have to divide the potential difference with the current at that point. You will get the resistance, which will be constant throughout the graph. Now what is resistance R? Resistance is the property of a conductor by virtue of which it opposes the flow of current flowing through it. The unit of resistance is ohm. Let us understand this statement first. Resistance is the property of a conductor which opposes the flow of charge. That means it opposes the flow of current. If we take a wire and at its one end it shows the current 10 ampere, so it is not necessary the other end will show the current of 10 ampere. It may show values slightly less than 10 ampere. Okay, so the remaining amount of energy is dissipated in the conductor because of this property. So it opposes the charges. Okay, it opposes the charge or the current. It depends upon the physical parameter as it increases with the increase in length and it decreases with the increase in cross section area. So a thin wire will have more resistance than a thick wire. So mathematically, equation first describe relations with the length, and equation second stabilize the relation between the resistance and the area of cross section. If we combine the equation first and second, it becomes R equals to R proportional to L by A, and on removing the constant of proportionality, we get another physical quantity that is called specific resistance or resistivity of the material, which is constant at a given temperature. Resistivity is not depend upon the physical parameter of the wire. Now what is resistivity? Resistivity depends on the nature of the material rather than its dimension, whereas the resistance of a conductor depends on its dimension as well as the nature of its material. So resistivity is the characteristics of a matter. It does not change with the change in dimension. If we change the length and the cross section of a wire simultaneously or differently, its resistivity will not get affected. So it will be affected only when the temperature of the wire changes. The SI unit of resistivity is ohm meter, and it is a scalar quantity. Let's summarize the topic. According to Ohm's law, V is proportional to I, provided the physical condition like pressure and temperature should remain unchanged. The Ohm's law takes the mathematical form as V equals to IR, where V is the potential difference and I is the current and R is the resistance of a conductor. Resistance is opposition to flow of charge or current inside a conductor. Resistance of a wire depends on length, area of cross section, temperature and nature of material. Resistivity of a wire is constant at a given temperature and is independent of any change occurs in length, area of cross section, but it gets changes with change in temperature. So this is the end of the video. Thanks for watching. Please subscribe to The Teacher Theory.